Hello, my name is Todd Evans, and I am a Level 2 Product Support Engineer at Cole Morgan. And this video series is an introduction to the AKD Ethernet IP servo drive. Welcome to video 15 of the AKD Ethernet IP video series. This video will discuss the different methods for reading or accessing a drive parameter over Ethernet IP. This is a common topic that comes up often after motion control is already implemented and is operating, but the programmer will need to access or change a parameter value for diagnostics or setup, such as recipes. Please reference video 9, which covers what diagnostics are already built into the static map of the cyclic data, that is, the command and response assemblies. Video 15 expands on this topic and supplements it by demonstrating how to add parameter access to information not built into the static map. The different methods for parameter access are as follows. The AKD read parameter write parameter method reads or writes from or to drive parameters. The AKD get attribute set attribute method reads or writes from or to the position controller attributes. There's also dynamic mapping, which we covered in video 10. Finally, there is explicit messaging, which uses the MSG or message instruction in RSLogix or Studio 5000, which is independent of cyclic communications. Each of these methods has pros and cons, which we will cover in this video. The AKD read and write parameter method accesses drive parameters as previously stated. It uses the command type hex 1F, which is the command type for the read or write a parameter. This is automatically facilitated using the AKD get parameter and AKD set parameter add-on instructions as shown. Pros are ease of access and use with the add-on instructions. Just look up the instance number. Cons are that it uses the cyclic data, the static map, to execute the method. Therefore, no other add-on instruction can be executing when the AKD get parameter or AKD set parameter add-on instructions are triggered. The AKD get parameter and AKD set parameter require that you specify a parameter instance number. Both the AKD Ethernet IP communications and AKD Ethernet IP RSLogix communication manuals have an Appendix B parameter listings for instance number and data size lookup. At the time of this presentation, the 32-bit versions of 64-bit or 8-byte parameters are not in the listings. You can see a screenshot from the manuals below, which shows the beginning of the instance and parameter list. In addition to the instance number and name, the list in Appendix B shows the data size and type. Add-on instructions are limited up to 4 bytes or 32-bit input and output data, a short int, an int, or a double int. The format of the tags to hold the read or write values in the PLC should follow the following convention. The chart shows on the left the AKD data size and on the right the equivalent AB PLC type. An alternative to using Appendix B parameter listing to find the instance number is using the Workbench GUI. Navigate to Device Settings, Communications, Ethernet IP, and the Command or Response tabs. This should look familiar to you if you've already viewed video 10 on dynamic mapping. This method includes the lookup of the 32-bit versions, 4-byte of the 8-byte parameter instances. If you look in the screenshot below, and let's just take for example the analog out.pscale, which is instance 13, and you can see that it's an 8-byte instance. However, the next instance after that, instance 14, is the aout.pscale, and in parentheses the 32-bit version. Next, I'm going to demonstrate using the AKD get parameter and AKD set parameter add-on instructions and how to look up instance numbers using Workbench. From Workbench, let's suppose in the application you want to change the distance after homing. You can select a field and right-click with your mouse and select parameter info. The parameter info indicates the keyword or parameter name for that field. In this case, the parameter name is home.dist. Now let's take a look at changing that parameter from the PLC over Ethernet IP. The first step is to determine the parameter's instance number. So I'm going to navigate device settings, communication, and Ethernet IP. For this demonstration, I'm going to select the response tab. I'm going to click configure. And then it shows an ID or instance number and the parameter name, size, and so forth. Keep in mind some instances are read-only and may only appear in the response tab, and some instances such as command parameters may only appear in the command tab. Instances that have read and write access may appear in both tab lists. From the search, I'm going to type home.dist and press the magnifying glass, and it filters and shows the instance numbers or IDs for any parameter related to that. And you'll notice the two that show up are instance number 199, which is the home.dist, and that's the 8-byte version. And then there's instance 200, which is the 32-bit version or 4-byte. Since the add-on instructions are limited to 4 bytes of inputs or outputs data, the 32-bit version or 4-byte is the one that we want. So you can write down and remember that the instance number that we want is going to be instance 200. Since we're merely using this as a lookup table and not actually using dynamic mapping, I'm going to click cancel. Okay, moving back to the PLC, you'll see that I created 2 rungs. One rung has an AKD set parameter add-on instruction, and the other has an AKD get parameter add-on instruction. Since these 2 add-on instructions have only a done and error bit and consistent with best practices, each add-on instruction has a trigger contact and a one-shot, and then also a parallel branch seal-in circuit that includes the enable in and then the done or error using normally open, normally close contacts, such that when you trigger it, it will enable and then it will disable when the instruction has executed and either done, success, or error, failure. I've given each one of these add-on instructions a unique instance name, and both point to axis_1 as the axis, which is consistent with the sample project. And you remember that the home.dist 32-bit version was instance number 200 when we looked it up with the lookup table. So both of these point to the same instance or parameter number. And then to store the value to be written or the value read, parameter value entry of each of these add-on instructions have a tag. Now you'll recall that instance 200 was 4 bytes, and so you can see hovering over these 2 tags, they're both declared as double integers. So in this demonstration, I'm going to start by setting a value that I want to write to the home.distance, and I'm just going to choose a value of 10,000 for example. So I'm going to toggle this, and it happens so fast you can't really see it, but it executed. And so if I move back to Workbench and look at the home screen, then you can see that the value was successfully written. I can go and change it to 20,000 if I wanted to, retrigger. Success. Now moving back to the PLC, if I want to get or read the parameter, toggle the trigger. And you can see that it read the value back. The AKD get attribute and AKD set attribute access the controller attributes. The AKD set attribute uses command type hex 1B and the load start bit in the control word. The AKD get attribute does not use a command type nor a load start bit. However, these methods are automatically facilitated by the AKD get attribute and AKD set attribute add-on instructions, as shown. Pros: ease of use with add-on instructions. Just look up the attribute ID number. Cons: uses cyclic data, the static map, therefore no other add-on instructions for that axis can be executing when the AKD get attribute or AKD set attribute add-on instructions are triggered. Limited list of attributes to get or set when compared to the drive parameter list. The AKD get attribute or AKD set attribute add-on instructions require that you specify the controller attribute ID number. Both the AKD Ethernet IP Communications and AKD Ethernet IP RS Logix communication manuals have an Appendix A position controller object hex 25 as shown below. Note there is a limited number of attributes from 1 through 101 below when compared to the parameter listings. In addition to the attribute ID and name, the access type, get set or get set, data type, and description are given in the list. Add-on instructions are limited up to 4 bytes or 32-bit input and output data, which is a short int, or double int. The format of the tags to hold the read or write value in the PLC should follow the following convention. The chart shows on the left the AKD data size, and on the right it shows the AB PLC type. Here is an example of attribute 100, which is home mode as indicated from the attribute table. The table indicates the parameter can be accessed by either get attribute or set attribute, and the data type is int or integer. From the screenshot below you can see there is a number associated with each home mode or type, such as 0 is current position, 4 is FIME home switch, and so forth. Now we're going to demonstrate using the AKD set attribute and AKD get attribute to write and read to the home.mode parameter via the home mode attribute in the position controller. From Workbench you can see that the current homing mode or type is 0 current position. Moving back to the PLC, you will see that I've added 2 rungs. The first rung uses the AKD set attribute add-on instruction, and the second rung uses the AKD get attribute add-on instruction. These add-on instructions have only a done and error output bit, so using best practices I've added a trigger, a one-shot, and then a parallel branch that includes the enable in and the done or error. In this case, when I trigger it, it will enable it and execute, and then one of 2 things will happen. Either I will get success, which is done, and then it will unlatch the seal-in branch, or it will error and fail. The 2 add-on instructions have a unique instance name, and they both point to the axis _1, which is consistent with the sample project. Both of these add-on instructions have an entry for attribute number, and you'll recall that the home mode attribute 100 is the attribute number that we want. Both of these point to that. And then there is an entry attribute value. So what I've done is I've created some PLC tags, one to hold or store the number that's to be set or written to that attribute to change the home mode, and the other is the get attribute tag that will hold the value that's read. The attribute value for the write, it could be a constant value, but for this demonstration I've declared a tag so I can make it variable. So the first thing we're going to do is I'm going to change this value to 4, home mode 4, and then I'm going to trigger it. It's done, which means it should be successful. And I go back to Workbench and you can see that the home mode has changed to 4. Likewise, I can go back to the PLC and choose a different mode, let's say 8 for example. I can re-trigger it. Click back in Workbench and it changed to 8. If I want to read back what the current home mode is, then I can trigger the AKD get attribute. I'll toggle the bit. It's finished, and you can see that it read back a value of 8. The third method for parameter access is dynamic mapping. If you've already watched video 10 of this series, you'll recall that dynamic mapping is facilitated by mapping the upper 36 to 63 bytes of the command and response assemblies with the Workbench GUI using the command and response tabs, or using the terminal using the EIP.cmd map and the EIP.RSP map commands, and enabled by the command assembly byte 33, where you set the map type to 2 for dynamic. The pros is this method provides parameter access that uses the upper bytes of the command and response assemblies and therefore do not conflict with any executing add-on instruction. It also allows data to be updated automatically on the POL without constantly triggering an add-on instruction. For example, the AKD get parameter add-on instruction. The cons is that it requires more setup and programming and not facilitated by add-on instructions. Please see video 10, Dynamic Mapping, of the AKD Ethernet IP video series for more details. The fourth and last method for Ethernet IP parameter access is explicit messaging. Explicit messaging is facilitated in RSLogix 5000 by the MSG or message instruction. The pros of this method are the parameter access does not use the cyclic data and therefore does not interfere with executing add-on instructions. It can be used to update data read or write for parameter access that is not required all the time or often, like if you were going to put it on the POL with dynamic mapping. This is sometimes called on-demand access. The cons is that it requires more setup and programming and not facilitated by add-on instructions. Please see video 16, Explicit Messaging, of the AKD Ethernet IP video series for more details. In summary, for parameter access over Ethernet IP, the order of communication efficiency from most efficient to least is dynamic mapping, explicit messaging, and add-on instruction read or writes. Dynamic mapping and explicit messaging do not interfere with the execution of the other add-on instructions, which use the static bytes of the command and response assemblies for a given axis. Since add-on instructions read or write, such as the AKD set or get parameter, AKD set or get attribute, are add-on instructions, no other add-on instruction can be executing at the time the add-on instruction read or write is triggered for a given axis. The order of ease of setup from easy to difficult is AOI read or write, explicit messaging, and dynamic mapping. Add-on instruction read or writes are easy. Look up the instance number or attribute ID and trigger the add-on instruction per best practices. Using the MSG or messaging instruction requires more steps to set up. Dynamic mapping requires mapping and byte consumption and address management, as well as turning on the data transfer map type equals 2 for dynamic. Note the order of efficiency versus ease of setup are opposite in order, so perhaps there is a trade-off. Which method is used is application dependent and up to the programmer.